Okay, hello, good morning. Can you hear me?
Yes, I can hear you. Good morning.
Okay, good morning. Okay, sorry for delay. So basically, just woke up. Okay.
Yeah,
Okay, so
it's
now
okay.
we'll start. Okay. Okay, so basically, today is our third number of class for water quality monitoring. Okay, so we will start. Just simply share my screen.
Mhm.
Can you see my screen?
Let's see. Not yet.
Now,
Okay, I can see it now.
so now let's go. Okay. Okay, so hi and welcome to the monitoring water quality using remote sensing technique in Polar engine. So basically today's session, I will try to discuss about that how we can easily monitor the biochemical oxygen demand, mainly BOD. It's very important factor for water. So how we can easily monitor the biochemical oxygen demand using Google Earth Engine, use of remote sensing technique. Okay. First of all, I will try to explain some basic things about that. What's the process to creating this type of biochemical oxygen demand, as well as what's the definition about the biochemical oxygen demand. So this something I will try to explain. Then further, I will show you that practical example about that. So biochemical oxygen demand and water. So biochemical oxygen demand represent the amount of oxygen consumed by bacteria and other microorganisms while they decompose organic matter under the aerobic oxygen is present and condition at the specific temperature. And further, biochemical is a measure of the amount of oxygen required to remove waste organic matter from water in the process of decomposition by aerobic bacteria. And the waste organic matter is established or made unobjectionable enough through the decomposition by leaving the bacterial organism which need to oxygen to do the work. And BOD is used to often in wastewater treatment plant as an index of the degree of organic pollution in water. So BOD values, suppose basically when you can get the higher BOD values indicating the more oxygen is required and which is less for oxygen demanding object it to feed on and significantly lower water quality. So basically where you find out that high BOD values, it indicating that this have polluted water because there are a lot of organism, there are a lot of phytoplankton, and this type of phytoplankton organism they need that lot mass of water. Okay, and higher BOD value indicating the more oxygen is required, and more oxygen is required when they have lot of bacteria, lot of organism, lot of phytoplankton. Okay, and when your water have lot of phytoplankton or lot of organism or lot of bacteria, it indicating the polluted water. Okay,
Okay.
and inversely low BOD values level oxygen being the removed from water, and so water is generally pure. So we also talk about the time series chart. So basically, when we can find out that a BOD value is the high, when we find out the BOD value is the low. Okay, so basically higher in BOD value indicating that water is more polluted, and lower in the BOD value is indicating the water is less polluted.
Okay.
So now method. What's the method we have to put in this time? So basically in this time we are use the method of Wang. Okay, so basically the BOD level is estimated using the empirical equation adapted from Wang. He already adapted this type of equation. So this is the equation about that 1.79 negative 0.789 multiply with B2 band, and then this is the plus 52.36 multiply with B3 band minus 3.28 multiply with B4 band. So this is the equation, and this equation mainly work for top of atmospheric satellite imagery. Landsat top of atmospheric satellite imagery. We use this equation, and this equation adapted from Wang. And we also check about the accuracy about that, how we can easily check the accuracy. So basically generate the sample data when you want to check your accuracy on your BOD map. we have to check the data. We need to take some data, BOD data with geolocation, including latitude, longitude, and BOD values. Suppose you just go to your study area or go to your water body, then take some sample with their including their latitude, longitude, and also you can take the laboratory test and find out the BOD value. And then this BOD value, we make a data set about that. It's our geolocation data. And further, we also create the predictive data. So basically, predictive data we can find out from satellite imagery. Okay, including the values predicted from the satellite imagery for the same location. Okay, for the same location, we have to check our predictive data. And further, we can create this type of equation. So basically, we can easily create an observed versus predicted BOD. We can find out that correlation about that. Our predicted data, which I get from satellite imagery, and our observed data, which I get from that sample on my ground truth data. Then further, we also make this type of things, and we can find out that R value, R squared value, we can easily find out about that. So today's session, I also show you that how we can easily check the accuracy of the BOD and create this type of chart, and also check about the R square value and R value. So basically, when you can get that R square value is the positive, so it means that our strong relationship with our map and BOD data. BOD data and predictive data, which I can get from satellite imagery, is strongly close, and we can find out that strong relationship between that observed and predictive data. Okay, so today's session I will try to explain all of those things one by one. So first of all, I will try to open a reference paper, mainly which paper I want to choose for the referencing. So I just open
If
the
I
paper.
wanted to
Yeah.
use surface reflectance,
Yes.
I would have to use a different equation for BOD.
Yes, yes, yes.
Okay.
I also show you the reference paper. It also more better. Just I open BOD from water using remote sensing, and there are already a lot of work already done using this one equation. We see adapted this equation, and now we are easily work with that. I can see this is the one kind of paper monitoring biochemical oxygen demand change during at that this study area using Landsat 8 satellite imagery in this like in Indonesia. So this is the reference paper. In this time, I will try to follow this paper, and then further I will explain all of method and also do this type of analysis using Google Earth Engine platform. It loaded. Okay, it loaded. It's loaded. In the meantime, I'll open the code editor. And I simply go to our data set, click on the browse data catalog. And here we have to use the top of atmospheric imagery, because this one equation is only work for that top of atmospheric imagery. I simply click on the Landsat, and further here you can see about that I click on the Landsat 8, I choose, and here you can see about the top of atmosphere. Okay, so this is my image collection. I have to simply click on here. So this image collection I have to use in my data set, and then further I want to adapt it the one equation, and then check about and create the BOD map, and further we also check our accuracy about this map. Why it takes some time?
Yeah.
I reload it again. Okay. So first of all, I just simply copy this snippet from here. This is my data set. I simply
Mhm.
copy and then paste in my code editor and then give a variable name. I put the name, suppose IMG. You can put any name. And I choose a study area. Suppose I want to work for that one area. I simply search there. Suppose lake of. Suppose I want to work for that lake. Okay. So this is my area. Okay, I want to choose this lake. So just
Okay.
I draw the story area for this lake. Suppose okay, it's I take a rectangle which covered the full area of lake. Okay, just I simply draw. Okay, okay, suppose I take from here. Yeah. So this is my
Mhm.
lake. Okay, so this is my study area. For this study area, I want to check about that water quality, monitoring about that. Okay, it's for this lake. So I simply draw this lake, and I put my study area name is that ROI. Okay, so this is my
Mhm.
study area. Okay, simply choose. And now from here, I just take the satellite imagery for this study area. So first of all, I need to filtering. So I put here the filter
Bounce.
bounce, which is ROI. I already defined the ROI, and then put here the dot uh, filter date. Filter date. I choose the year of suppose 2021. 2021. 1st January from year of 2021. December 31. I take the whole 1 year imagery, and all of image I choose only for the image which image will be not more than 1% cloud cover. So just I put here that cloud cover, put at that less than 1, and further I create that median composite, and it also clip with my study area which is ROI. And further I want to visualize this image, so just put here map dot add layer and call the IMG, click the run. So now it loaded a image, so I run the code. Okay, ROI is the lowercase, so it's put at the lowercase, click the run. Now it worked. In this time I face this type of problem. Here you can see it not show about this type of place. Okay, in this time it means that for this place there is no image which is less than 1. I simply increase the value, suppose less than 5, and then try to check
Okay.
again it will be fully covered or not. Okay, so now it's fully covered. You can see we can get this
That's
type of,
less than 5%.
yeah. In this time when I put at the less
Okay.
than 1, you can see it just show you only for this place which place is only available for the less than 1% cloud cover. So this place is less than 1% cloud cover is available for my study area. Okay, but I need the
Okay.
full cover. I need to full coverage this area. So for that I also increase the cloud cover level. I put here the less than 5%. So now I can see when I run the code, it will be fully covered my study area.
Mhm.
Okay.
Okay.
So now further, I want to add the color. Suppose I just click on here and I set here suppose true color composite B4, B3, and B2. Red, green, and blue. Custom stuff 98%. Apply. So now we find out this type of imagery. Okay. and I also put here the suppose B5, B4, and B2 is custom stressing 98%.
Do
And
I
now
have to choose three bands? I can't choose two.
yeah, so basically 3 band make a one combination. Suppose red, green, and blue.
Mm-hmm.
Suppose red, green, and blue. B4 is the red, then B3 green and blue. Suppose 3 band create the natural color. Okay, so basically this
Okay.
it's one kind of satellite image visualization process. Satellite image is only for the band. Suppose B1, B2, B3, B6, all of those band. When I
Uh-huh.
want to make the combination, suppose I make the combination B4, B3, and B2, it called the red, green, and blue RGB color. Okay, RGB color, it's also called the natural color. When I put
Okay.
at the B5, B4, and B2, then I can get this type of color. In this time, you can say I can easily find out this type of red, black color. This type of black color is identified about the water body. It's water
Okay.
body. Okay.
So it
So
can't be two. It has to be three bands.
yes, yes. Suppose I
Okay.
put at that B4, B4, B3, B2, 98%, and apply. So now you can get the true color. It's called that natural color. Red,
Mhm.
green, and blue. Okay?
Okay.
Naturally, which we can get. Suppose I put here that another, suppose you can see the B6 short wave infrared, then put here that near infrared and blue, custom stress in 98%, and apply. So now we can get this type of color here again. So we can easily identify this is the water body. Okay, this is the water body.
Mm-hmm.
Okay, so now suppose you can basically it's one kind of visualization process of satellite imagery. So just I simply import that and then copy this variable and paste after the object name
Okay.
and put here that imagery. So this is my imagery. Okay, I got my imagery. So now from this imagery, I want to find out the water body. Okay, I want to make the separation. Okay, suppose it's a one image. Okay, it's just a one image. From this image I just extract the water body. So this is my water body, also have a water body in here.
Mm-hmm.
So just I extract the water body, and further for this water body I want to observe what is the condition about the BOD. I want to apply the Wang equation about that. Okay, why it's not opening? Hmm. Okay, I will send you this link. You try to open your computer. It and later.
Okay.
Simply go to this link. It will be open. Okay. So now this is my satellite imagery. So from this satellite imagery, now I want to extract about the water body from the satellite imagery. So for doing these things, I just work with, suppose I want to work for that, suppose NWI. So I want to extract the water body. So for that, I just take a function. I just take a variable name, suppose MNDWF, and I put here the equal sign and function keyword, and I put here that image. In this curly bracket, I put here that uh, just I put a equation of MNDWI. Only modified normalized difference water index. I want to apply in here. I call my element name image, and I put here a function normalized difference. between the two band. One is that green B3, another is short wave infrared, which is B6. Okay, so basically it's an equation for that MNDWI. Simply search here Google, suppose MNDWI for Landsat 8. I simply search on the Google. Then I can easily get, you can see green band minus short wave infrared band divided by green band plus short wave infrared band. So this is the equation for MNDWI. Okay, so in this time I simply put this equation, and in this time when I put at the function normalized difference function, it automatically calculated B3 minus B6 divided by B3 plus B6. When I put at the normalized difference function, it automatically calculated. Okay, after that I put at that rename function, I put the new name. So I put the name is that MNDWI, and further I want to return from here, so just put here the return this image add bands of MNDW, just this variable. I simply paste here. Return this as the bands about the NDWI. And then further I put here that update marks of MNDWI greater than or so now I can get this type of lake. Here we can find out. Okay, so you can see this is my satellite image, and I just extract the water body from here, and you can see. Okay, so this is my imagery. So from this imagery I just extract the water body. So this is the water body, and further I just check about the BOD. So it look like that. I simply click on here. When I stressing this thing, suppose just stressing 98%, then apply. Now I can get this type of things here, you can see. So basically this type of region, it show about that high concentration about that. Okay, and this type of things is the about that low. So basically I just click on here, and then I can check about this hello. To find out that 8 milligram per liter, this type of region, I find out. And it means that for this water body, there are the lot of BOD. Basically, oxygen is required for that different types of phytoplankton, or also need for that different types of bacteria. Okay, for their work, there are the lot of oxygen required for this water body. You can easily get it from this idea.
Okay.
So you can see it for this type of thing. So I just click on here. Blue color show about the low. You can get the 6. So this type of color show about that. Okay. To check this leg of bacteria. So further, I simply remove the previous RY, delete, and take the new rectangle about this leg. And I choose suppose less than 1, and then check whatever. Basically, you try to put the very low cloud imagery, then it will also get the more better result. So just I put here that RY and click run. In this way, you can see it look like that. Some part is missing. You can see this part is not showing in here. It means that this is not available for the less than 1%. So I try to increase suppose 2. So now try to check. Okay, it also not. Suppose put at the 3. Okay, so it's cover almost, but one part is missing. So I put at that 4. Okay, it's not also cover. So I put at the suppose 5.
And that's because you're using the median, right?
Yes.
If you weren't using the median, then it would just not show an image or show the image.
Yeah.
Okay.
Okay, so now you can see here we can get it fill up. So basically this region have available less than 6% cloud cover imagery is available. So that's why I can get this type of things. And in this time here you can see from this lake we can easily get this idea. So this type of place we find out that high concentration of BOD value. You can see it look like that. Suppose if you want to click on here, just click Inspector tab and click on here, then we can get the result about the BOD value. You can see 26 milligram per liter. So for this is a region, there are a lot of trees or phytoplankton or other types of bacteria. Okay, it's available for this. It shows about the very high demand of oxygen. Also click on here. And you can think about the value 7 milligram per liter. Suppose try to check this lake of and check it. So just click on here and then remove that. Further, I take the new. Just I increase the size, and I put at the less than 1%, and then try to change the name. I put the name RY. Then click on run. So now I can get the result from here. Okay, so it's worked pretty well. Yep. So further, just click on here and custom support 98% for better looking about that. Apply. So now you can get this type of things here. You can see. You find out. You can see here type of result. So this type of things is the red color identify about the high, indicating of that BOD value. Blue green identify about the low. Okay, and this type of color is that medium. So click on here, you can get about the result. You can see 5 milligram per liter. Also click the red color. So it need that very much demand of oxygen. You can see 9 milligram per liter about that. Now then check for this leg. So for that, simply click on here. I remove this. Just click on here and draw your study area. Look like that. And I put here that variable name is RY. And click run. You can see it look like that worked. So we find out the imagery. So first of all, you can see this is my imagery. From this imagery, I just extract the water body and then you extract the BOD. So just click on here and then stressing 98%. Then we also get the more better result about that. So apply. So now we can easily get about that. You can see the result. This type of red color identify about that high concentration of the BOD value. Okay. High demand of high requirement or about the BOD value. And this type of blue color identify about the low. You can get the very better visualization because this study is also available for that less than 1% cloud cover image is available. So you can see it look more better map about that. Okay. So now we talk about the time series chart. Suppose when the BOD value is the high, when the BOD value is the low, we try to find out these things from here also. For doing this time series chart, I just take a variable, suppose BOD chart UI dot chart. So further, I just extract the water body from. I just extract the pixel value. Suppose BOD pixel value for each point. So this is my predicted BOD, which I gain from that satellite imagery. So further, when I can get the two data set, then I can easily check the accuracy using this code about that, and also make that correlation chart. It working?
Oh, it's a little slow.
Hmm. Okay, done. So just I simply click on the refresh, and you can see about that VOD sample. Okay, you can see. Okay, so it shows that this tab will not be valid geometry. I think some problem on the geolocation. So let me run the code again. I think some network issue. Okay, so let's work. I just put here the suppose RY is my point. I want to just use here map dot add layer of RY, and also map dot center object of RY. Then click to run. At the point. Okay, so I think it's a ready-made data set. Okay, so for that, we have also need to learn about that how we can easily create this type of things. Okay, suppose longitude, latitude. So basically, it has some problem for this. So when you want to work with the real-time data set, suppose you can simply check the geolocation. Different types of device we can also get for checking GPS machine or GPS tracking. We can just simply open it, and then we can put at the longitude, latitude, and also take the water sample. Okay, further this water sample we can simply check our laboratory and take the BOD value. Okay, and further this type of predicted BOD value we can collect from our satellite imagery, same location. In this time I think some problem in this location, so but we have to use the same location and extract this type of pixel value for each location, which value I can get from the satellite imagery. So further we are just use this type of code and then check about the accuracy. Okay, so further I also discuss about the real-time data set. Suppose another parameter, how we can easily check the extract the pixel value. Then I hope we can easily get this idea how it will work. Okay. Okay, so today is no more. I will send you all of recorded class. I think the last class is also not sent. So I will say both of class I will also send you at the same time. Yeah. And also send you that this type of practice code. You also try to practice and also do this type of things. Okay?
Yes.
Yes.
Okay.
Okay. Okay.
Yeah,
Okay,
sounds
thank
good.
you. Yeah, please.
Okay. Thank you.
Okay, thank you. Okay, thank you. Okay, have a good day. Okay, bye.
Bye bye.
Bye bye.